Hello, it's Keith here, and this is lesson 6 of the simple series of my 68,000 assembly programming tutorials. In this series, each week we create a simple bitmap on the screen on a different system. This time it's going to be the Neo Geo. We're going to be creating a smiley face in a single tile, and then we're going to create a larger character, our Chibico mascot, in a 48 by 48 tile grid. Now, you may be a bit surprised I'm saying tiles if you know the Neo Geo, because the Neo Geo is actually only a sprite-based system. We're going to be using the fix layer, which is really designed for doing just simple lettering, to do the graphics in this case. If that's not good enough for you, please see my platform-specific series. I've covered sprites, and I've covered using the sprites to create a tile map. But this is designed as a sort of beginner's tutorial, and I think you can create a really decent game on the Neo Geo with just the fix layer to get you started. You know, if you were creating your Pong or your Frogger kind of game, you could do that with the fix layer, and I think if you're a beginner, that should be what you should aim at. Anyway, let's go over to the source code and let's check out today's examples. Okay, so here's today's example. Let's just fire it up here. It's just taking a little time to boot up, and it's a little bit small. So there's our first example, just a little smiley face. That's an 8 by 8 graphic there, so that's a single tile. Now, that's not the only one. My XML is just firing up there. We'll discuss XML in a moment. Every time I compile this, the XML has to recalculate the checksums, you see. So here is our Chibico character, and that's 48 by 48, so 6 tiles wide and 6 tiles tall. And we've broken up the image into individual tiles. Now, if you're wondering how you can create your own images, well, what you need to do is you need to export them as a ROM and then include that in the XML, which is why that kept popping up. Now, I've got them in this fix area because, as I say, they're using the fix map. So there's two here. That's the Chibico character, and that's the smiley face. Now, you'll need to export them in the correct format, and it's a bit tricky. So what I'd suggest you do is, if you go to my website and get the Aquasprite editor, it's actually included in the sources 7-zip for these tutorials. And what you can do is you can go to 68,000 and you can go to Neo Geo and you can do save fix bitmap. Now that will, if you use a small image, that will just save it as a single bitmap. But if you use a larger image like this, it will break it up into individual 8 by 8 images and store them in that ROM file. Then what you need to do is you need to include them in the fix area of your MAME XML. If you're using MAME, if you're not, then you're going to have to figure it out yourself. Sorry. You can include those files at the correct offsets. The offsets will define the tile number that it appears as within the code that we see later on. Now, of course, if you're worrying about this thinking it's tricky, it definitely is, I don't deny that, but you can download the development tools that I've got here. It's just a copy of Notepad++ with a few batch file scripts I've written and a program that will calculate the checksums and the size of the ROMs for you automatically. So I'd suggest you try doing that, and hopefully that'll work out fine for you. It should do. So yeah, as I say, that should help you get started if you're just new to this. Okay. So we're going to go over the source code. We're going to go over it pretty quickly because a lot of it is quite long and complicated. And if you're just a beginner, I'd strongly suggest you just download my example code. First, we've got the header here. You can see I had to sort of base this on the one from this website here. See, there's a lot of different settings here you need to set up. So all of these you can just leave as is, really. You can see here there's a lot of bias functions we need to define, and there's a lot of sort of generic handlers here that will just basically keep everything satisfied, so to speak. Now you can see here we've got this thing called kicking the watchdog. This is something you'll hear quite a lot. On the Neo Geo, the system, because it was designed for an arcade, had the ability to reboot the machine automatically if it crashed. And the way that this worked is the software had to tell the operating system that it hadn't crashed, and if it stopped telling the operating system, the operating system would reboot it. The hardware, rather, the BIOS of the machine would reboot it. And so we have to do this kicking of the watchdog to tell the system, hey, I'm working right, I'm not crashed yet. So so that we're going to see that quite a lot. Here we've got some generic routines to handle system events. Here's a VBlank routine for when the screen's redrawing. More generic routines. You can see we're having to kick that watchdog. And here is the start of our actual game code. This is our program. And again, a kick of that watchdog. Keep the watchdog in check there. We're then defining our colors here. Now we're defining the background using this weird color here. The actual palette for our sprite is with these ones. Now each one is 2 bytes, and the top nibble is unused. The remaining 3 nibbles are in red, green, blue format. Once we've done that, we're then using two system routines just to clear the fixed layer and the start of the sprites, because otherwise we may have some garbage showing on the screen. Okay. Now, with other systems, we would actually need to do some kind of definition of the tiles in video memory, but we're using ROM here, so all of the work is done by that XML file. So all we need to do at this point is actually calculate the address in our fixed map. The tile we're going to want to use is number 512. We then need to define the top two parts of that. Now, our first tile of our smiley face or our Chibico character isn't the first tile of the fixed map, because the first ones are actually being used here by the ROM. So what we're doing here, we're just having to add an extra hexadecimal 800 here for the start of that. We're also selecting palette 1, which is defined by these colors here. Now, what we're doing next is we're calculating the memory address of the position we want to show on screen. We're using position 3,3. The fixed map starts at VRAM address 7000 here, and rather oddly, the fixed map is actually rotated through 90 degrees, whereas most systems, the memory addresses would go across the screen. On the Neo Geo, they actually go down the screen. So we're having to multiply our X address by 32 and then add our Y address and add all of that to hexadecimal 7000 to select the video RAM address of the tile that we want to show on the screen. We then write that address to hexadecimal 3C quadruple 0 here, and then we write the calculated tile number, the one we calculated up here, to 3C002. And that's actually all it takes to draw a tile on the screen. So this is calculating the memory address defined by these bytes here, the X and Y position, and this is setting that tile visible on the screen. So that's all we need to do to draw a single smiley bitmap on the screen. Well, what if we want to do something a bit bigger? As I say, we've got that Chibico example. Let's see the Chibico example again. So here it is. Now this time, if NeoGeo starts up on time, this time we've got a much bigger image, so we're having to split that up into individual tiles. Now, the actual job of defining the image is being done by our sprite editor, so all we need to do here is actually define the visible tiles on the screen here. So what we're doing here is we're calculating our tile number once again. So we're defining our tile number here in D4, and we're starting from 256 this time. Last time we started from 512. The reason for that is there are different memory addresses in that XML again. So we're starting from 256 this time. We've got a position of 3,3, a width of 6 and a height of 6 as well. That's because it's a 48 by 48 bitmap and each tile is 8 by 8. Here we're calculating that first tile number. We're then going to start a loop and we're going to write the tile data to the screen. Now what we're doing here is we are calculating the address of the first tile. We're going across the screen, so we're calculating the address of the first tile here, and we're then writing the tile address and then the tile number. We're increasing the tile number and we want to move the tile address across one, but remember it goes down the screen like this, so rather than just doing an increment, we're actually adding 32 and that will move us across one. So we're adding 32 to the VRAM address and we're adding 1 to the tile number, and then we're repeating for the X loop. Once we've done that, we come out of the X loop, we move the Y address down and we repeat back up here and recalculate the address accordingly. Now, if you wanted to use this kind of thing in your own code, of course, if you wanted to use a bigger or smaller bitmap, you just change the settings here. If the bitmap was half the width and half the height, we just run again. Well, now you can see we've just drawn a smaller area, and the image is of course a bit garbled, and that's because the image wasn't exported in that size. So there we go. As I say, this should hopefully be a nice starting point for you to get started writing a very simple game. I'd suggest you have a look at this. If you've not seen the Hello World example as well for the Neo Geo, it's probably worth you looking at that. That also used the fixed layer. And if you want to see more, as I say, I've already done in the platform specific series how to use the sprites as sprites and how to use the sprites as a tile map, because the Neo Geo does not have a tile map. As I say, you can download the development scripts that I've got here, and you should just be able to assemble just by pressing F6 and selecting Neo Geo from the options. Anyway, that's all we're covering today. Next time we're going to be taking this example and adding joystick control, and we're going to move that smiley around the screen. But I hope you found it interesting today. I hope you're going to give assembly programming on the Neo Geo a go, and I hope you enjoy programming in general. Thanks for watching today, and goodbye.